Hi, everyone. Thank you for joining. And I'm going to walk through the agenda right now, and then we'll get started with the demo and the discussion around, what we are going to do in the webinar. Right. So essentially, the agenda for the session is, I'll walk through a whole data flow for a prediction use case, right, based on a classic Titanic data set, and the data flow will contain, it will contain all the common usages which we see as a data engineer, as a data scientist, what we use. And the topics we will cover is, on the data engineering side, we will look at how we can extract the data, how we can do exploratory analysis, how we can clean the data. And then we'll jump into the data science workflow. We will look at how we can create a ML workflow, how we can train the model, how we can tune the model and do hyperparameter tuning and register the model using MLflow, right? And then what deployment options do we have, in terms of model serving, how do we serve in batch and stream, and then how do we, serve via web service, right? So this is the agenda, and so I hope that you all know what Databricks analytics, the platform as such is all about, right? So it's essentially it's a one-stop stop for your entire analytics journey, right? So it has got workspaces. It has got Databricks runtime, right, where you can run your Spark, your ML pipelines. Right, it works on Azure, it works on AWS, and there's also a community edition, which we typically use for our experimentation and whatnot, right? And it has a rich ecosystem of ML frameworks, and you can bring your own framework as well, and you can use the best of technologies when it comes to Databricks, right? And so on the data engineering and the data science, like the complete data and ML lifecycle is accelerated through this platform, right? So that's the beauty of this platform. And as you all know, it's a popular platform, and Databricks, they also host every year they host AI Summit as well, so which is very popular. So that's the beauty of Spark Databricks, where the company actually who created Spark, the Apache Spark framework, back in the early days from Berkeley, and then it has become a very popular distributed computing framework. So I'll stop sharing this one, and I'll directly go into the Databricks demo, and we'll walk you through the rest of the content. Yeah, give me a moment while I switch off this and share my screen again. Yeah.
Yeah, Abhishek, I was able to see your screen. Please
Okay,
go.
good. Yeah. All right. So we'll go into the exact use case over here, right? So agenda I have already covered. I'll just quickly go into the introduction of Spark. I think many of you already know what Spark is all about, so I'll skip this part, right? In terms of Databricks terminology, right? So these are some of the things which we commonly use, right? Workspaces. They allow you to organize your work. So you as a end user, you will have your own environment, your own sandbox, where you can save your notebooks, your libraries, right? You can share and collaborate with the other users, and you can also if you don't want to share, if that is also possible, right? So it depends on the environment which is created and how it is federated across the organization, right? Notebooks are just like typical feel of a Jupyter notebook, so it's very similar to that, right? So you can use it exactly in that same manner, a very user-friendly way of coding and running your code and testing it out, right? And you can bring in your libraries, your custom libraries, your Python egg files, right? Your Scala or Java jars, right? You can package it and you can upload it, right? Or you can even install it using PyPy, right? So when we talk about tables, tables are essentially the structured data, right? So you would create a Spark table or a Delta table using Databricks, and then you would use that for your data engineering or your data science pipeline, right? Cluster is basically the compute, right? So you attach your notebook to your cluster, and based on that, it runs your code, and then it is able to do the exact functionality in terms of data engineering or running your ML pipeline, right? Jobs are essentially something where you can execute. So you can execute your notebook through API or through the notebook as well, right? So those are typically, you can monitor the jobs through the Databricks platform, and yeah. So in terms of the architecture, I mean, this is the Spark architecture. I think all of you are aware of the architecture, right? It has a driver and it has got multiple executors, right? And this is how it basically runs, right? The driver sends the tasks to the empty slots, and then the executors has the work to be done, right? And it executes, right? This is typical of how a distributed system works like. And there are two types of operations which are commonly done. One is the transformation and the other one is the action, right? So transformations are operations which that will not be completed at the time when you write it and execute. It will execute only when you call an action, right? So these are some of the actions which we know about, right? Show, count, collect, save, right? And these are the lazy transformations as we know them, right? Select, distinct, group by, sum, order by, filter, limit, right? So this is how a Spark pipeline is created behind the scenes. We do a read operation, right? We do a filter, an aggregate, right? And then it shuffles when we it shuffles because we aggregate, and then we write it, and then it goes on, right? And then it depends on what we are trying to do as part of our code, right? So, and this is an example of the internals of how your the transformations and actions work, right? So in terms of the data frame and the Spark SQL, right? So you have a SQL abstract syntax tree and a data frame, right? Which then gets created. That creates a logical plan which is unresolved, and then it gets optimized by the optimizer which is internal to the Spark, right? And then it creates the physical plans, and then it does a cost optimization, a cost model optimization, and selects the physical plan, and then goes into the code generation, right? So this is how how internally it works, right? How it builds the plan, how it compares, and then finally it chooses the best and then executes it, right? So in terms of Databricks runtimes and Spark clusters, right? So Databricks is designed for the cloud, right? So today, Databricks, it does not work on your data center. So just that it works on AWS, Azure, Alibaba Cloud, right? And in the future, I'm sure they will add the other cloud providers like Google or and whatnot, right? So it's designed for the cloud. So in other words, right, it means that there's a complete decoupling of your storage and compute, right? And there's a concept of ephemeral clusters, which means transient clusters, right? So you create your cluster, you do your job, and then you shut down your cluster or terminate your cluster, right? That is how you save cost, right? And you can create multiple clusters. Different users can create their own clusters. You can also have shared clusters. So there are two types of clusters, right? You can have an interactive cluster, or you can have a job cluster, right? And clusters typically take few minutes. With a pool, you can do it instantaneously because you have the pool of compute ready for you, right? So it has got a lot of other features like ACLs, access control list. You have endpoints for your dashboards, right? And some of the other features are driver fault or isolation and preemption, query watchdog, ACLs, as I said. It has got the optimized. So there's a basic difference between the Spark open source and the Databricks Spark. So Spark on Databricks is much more optimized, and it has got the Databricks claims that it is at least 5 to 8 times faster than the open source Spark 3.0. Right. So that's one of the main differences, between what Spark is on Databricks versus what is on open source. Right. So when it comes to workspace and notebooks, right, so we have all these features, as I spoke about, collaboration and visualizations, history of notebooks can be maintained, etc., right, library management, etc., right. So as I was saying on the performance, right, so this is what I was talking about, right. Data Spark on Databricks is 5 times faster than Apache Spark on AWS, 8 times faster than Presto, and 3 times faster than Impala, right, on Cloudera. And these are the basic tenets of what Spark comprises of. There's a data set, there's a data frame, and there's an RDD. Data set is a typed interface, and where you can access both the features of RDD as well as data frames, but this works only with Scala Spark. In PySpark, we don't have this option. Data frame is the most commonly used concept. It's very similar to what we do say with Python, Panda, as well as the R. So it's very synonymous to that, right? RDD is the lowest level of data structure, which is distributed across your cluster. And essentially, if you have very custom logic which you need to implement, we use RDDs, right? So I'll move on into the actual demo. And I've already started a cluster. As you can see, it's a single node cluster, 16 GB with 4 cores, and it's using the latest Spark. And yeah, it's, I think, 1 DBU. Right. So before I start, right, so some of the other concepts, right? Databricks file system. So there's an abstraction which is provided by Databricks, by which you can mount your actual object store, or your where your files are on the cloud, right? So it allows you to mount your containers, and so that you can use the DBFS file system, the file system, without requiring any credentials. It makes it very easy for you to access the files and to manipulate and do whatnot, right? So yeah, cluster setup, everything is done. So I'll just start. And then as you can see over here, what we are doing is we are using the Titanic data, which is a very popular data set, which we typically use when we start learning data science. So I picked that because it's very easy to correlate of what we have done already with, say, typical Python based data science. So it'll take a minute. Actually, I can run all of them. Yeah. Okay. Yeah. So the first one, basically it's set up. I mean, there was nothing much. It just created a database. And then over here, I'm pulling the data set from GitHub. And then yeah, there are some important concepts of DB utils, right? So DB utils is very useful. We have various options of using the DB utils. We can do copy, and we can list the files, we can move the files, etc. We can mount, unmount. So these are important file system activities which we can do on the Databricks platform, right? And then this one it already ran. As you can see, I ran all the commands actually together so that we can move faster. So this created a path and it put it in it copied the file to that path, right? And then now you can see the file is now located in my user directory, right? And now this is how we read the file. So we load it into a data frame, right? So we pull the file from the data path, and then right, we input the schema, and the header is there, so the header is true, and then we cache it, right? So to process the data in memory. So this is how the data looks like, right? So we have all these attributes, right? We have the survival, the passenger class, the sex, the age, and some of the other attributes, right? And a passenger class is important because Titanic had that first class, upper class, middle, and the lower berths, right? So based on that, a lot of based on the socioeconomic status in those days, you would buy the tickets, and that is how you were placed in the ship, right? The age and the sibling determine some of the other attributes, right? And then we save that this data set into a Delta table, right? And this is how, if we want to visualize the data using Spark SQL, this is how we do it. This is the inferred schema, right? So we just do a print schema, and it shows you, how the schema is for that data set, right? So this is the summary. This is how we can describe the data. So it kind of does a profiling of your data set, right? So there are 891 rows, and the mean of each attribute, the standard deviation, the min, the max, all the things are specified over here, right? And this is how we do a simple EDA, right? So we do a group by on survived, and then we do a count, and this is right. So 62% did not survive, and 38% survived, right? One over here it means that basically you survived, right? One is yes, and 0 is no, right? So this is one more, we are trying to group by based on survive and the sex, right? So as we can see, the female passenger survived more than the male, in the Titanic, based on the data set which we see, right? And these are the counts. And then we group by on the passenger class, right? And we see that there are more survivors for the first class or the upper class, and as we go into the next classes of passenger classes, right, we see that there's a decline. Very few actually survived from the P class equal to 3. Okay, going into the next one. So I'll just run all again so that we can move fast over here, right? So we're again reading the table back. So we'll see what we are doing with respect to the cleaning, right? What kind of cleaning we need to do. Mostly if you follow the data science, right? We remove the nulls, we check what kind of data is there, categorical, numerical data, and then based on the features which we think are important, we do certain things with that. So we'll see how we can do it with Spark and on Databricks, right? So as you can see, 891, right? It's pretty much the same thing. And now we rename some of the columns which we think are important, right? So we rename P class into passenger class, this into sibling spouses, and this into parents children, right? So this is how you do it with Spark with column renamed, right? And we save that into another data frame called Titanic clean DF, right? And we print the schema, and we drop some of the columns which we think are not important, right? Like passenger ID. So passenger ID, if you see, right, it's just a sequence number. It is not going to influence your model in any way, right? And then we drop names, also not so important. It doesn't matter what your name was, right? And ticket and cabin, right? So the ticket number and the cabin number, those are also not of any importance, right? So we drop all those columns, and then we print the schema. So now we see we have a lesser number of attributes, right? We remove the null values. So we drop all the rows containing null values. I mean, this is something which you can do. You can choose other ways of imputing null values as well. But in this example, we have just dropped the null values. This is how we convert a categorically column into a numerical, right? So we use the string indexer function over here, right? And we are doing basically label encoding. So for the columns sex and embarked, we are converting that. We are creating a pipeline with the string indexer, and then we are creating that new encoding, or we are encoding these two attributes, right? And the new name of the new columns would be that column underscore index. So sex underscore index, embarked underscore index, right? So as you can see over here, male becomes 0, female becomes 1, right? And similarly for embarked, we have S and C. So based on that, you have the zeros and the ones, right? And it does that automatically with this feature of string indexer. Then we drop the columns, because now we have encoded the categorical column. So we don't need the S and we don't need the embarked and the sex column. So we drop them. That is what we are doing over here. And now we save this into another table, delta table, which we call as Titanic clean, right? And we see that the count is 712 now. Initially it was 891, if you remember. Right, so we'll move into the next one. Right, so what is machine learning? So I think this is very easy for folks who already are into ML, right? So I'll just keep it short over here, right? So classical programming, we know that rules and data, right? If you write a program, you get an answer, right? So in machine learning, we are trying to learn the rules, right? So we give the data, we give the answers, which we have seen previously, and then we try to model that and get a specific rule. A rule is something like an equation, right? So that is how you can imagine what a rule means, right? So we are trying to model an equation with which we can predict what your answer is going to be the next time when you feed new data into your ML rule or ML model, as we call, right? And we try to predict that answer, right? And the answer could be, in terms of you're trying to classify something, you're trying to predict a value or whatnot, right? Right. So this is, machine learning typically is or categorized into two main types, right? So we have supervised learning, we have unsupervised learning. Right. So in supervised learning, we know what we are trying to predict, right? So we know the label in terms of in our example, this is a supervised learning, right? So we are trying to predict whether the passenger survived or not, right? Based on certain features, right? So the output is a survival status, and we are learning the data because we've seen that, we know what labels we have and what the features we have. And based on that, we are doing unsupervised. We we don't know, what, so we are trying to discover the data. It's more around, there's no known output. So a clustering is a good example of, unsupervised learning. Right. So because the goal is to discover how the data is organized, etc. Right. So going into some other, initial topics of ML, right? Regression versus classification. This also, I think a lot of you already know about, right? So quantitative values and typical, numeric values. They have, positive, negative values, right? These are some examples, right? Quantitative are also known as continuous or, numerical values, right? And these are the examples, right? Qualitative could be a categorical attribute, right? It could be a gender, it could be whether the patient has cancer, a state of residence, and whatnot, right? So this is, typically, when we are trying to find out a quantitative variable, then we do regression, right? We are trying to extrapolate that with an equation, and we are trying to predict what the value is going to be, right? And for classification, we are trying to classify, right, whether the patient has cancer or whether it does not have cancer, whether the passenger survived or did not survive, etc. Right. So what is feature engineering? I think we know this term, we've heard about this term, right? So feature is nothing but the attribute which we think is important for the purpose of your ML pipeline, right? So we use our domain knowledge, we use our statistical knowledge, and we try to figure out, what are the features which are important, right? Which features should we extract, which features should we select, right? And how do we, maybe we create new features from the raw data, right? And we try to learn that. So going into SparkMLLib, right? So Spark has a ML library which is called MLlib, right? And the goal is, right, for any Spark end user, it makes it very easy to do ML scalable, because now you're talking about doing your ML in a distributed computing framework, right, in cluster, right? In our example, obviously, we are using a single node, but in all practical, purposes, right, we will have a multi-node cluster, right? So that is how we will run, or maybe we will use a GPU environment, right, which has multiple cores, right? So in all practicality, we will try to distribute our ML pipeline in a way so that it runs faster with bigger data sets, right? Typically for deep learning, we will try to use GPU, and for others, we will try to use some form of distributed computing, right? Because we don't want to wait for hours to get something out of that, right? So that's the main idea behind why you want to distribute and run your pipeline, be it your data engineering pipeline or your ML pipeline. Right. So along with that, ML ops is a very important aspect, right? Machine learning lifecycle management, right? So how do you operationalize your ML pipeline, right? So MLflow is something which was created, it's open source framework, or open source platform rather, right, for managing the end-to-end machine learning lifecycle, right? So there are 4 primary functions, right? So you can track your experiments, you can package your ML code, you can manage and deploy models, and you can also provide us a central model store, right? So, we have different ways of doing it. Usually, there's a logging API by which you can track, right? And then you can run based on every experiment, right? You capture the parameters, the metrics, the artifacts, and the source, right? And then the model registry, right, which allows you to register your models, experiment your run your experiments, and then deploy your model into different stages, maybe into staging, into QA, into production, right? You can archive your models. So this is what MLflow is all about, right? And you may have already used it, but I'm just trying to do a recap over here, right? So there's an MLflow tracking server, as I was saying, so which kind of tracks your parameters, your metrics, right? And there's a model registry, where you graduate your models from one stage to another, and you keep on testing them, right? So whenever there is a drift in your model, you build your maybe you will recreate your model, or maybe you'll tweak few parameters, or add a new feature and whatnot, right? And maybe you'll archive the old model, right? You'll deprecate it. and then you will deploy the model, right? So that, maybe you'll create a REST API, and then that will help you serve your model for your downstream applications or users, right? So we'll just go into more ML workflows now. So again, we'll try to run this. Right. So in this notebook, right? So what are we trying to do? We are trying to define a data analytics development cycle. We will split the data set into training and test data. We'll track the model development with MLflow. We will train a baseline model and we'll evaluate that performance. We will also train a decision tree, right, as an alternative, and then we will evaluate the decision trees model's performance as well. Right, so this is a development cycle. I think all of you must be aware of this, right? So whenever we get a data science use case, we try to do a business understanding. We try to learn the data, right? We prepare the data. We then try to come up with a model. We evaluate the model, and then if it does not work well, if we see it's not so good, we again go back. We go through this whole cycle, and then finally, once we get the best model, we deploy it. Right, so this is a typical development cycle, right, for a data science use case. And to implement the development cycle, right, we basically first need to divide the data randomly into two subsets, right? We create a training set and a test set. So this is also a very, this is an important step. Obviously, a lot of us already know this, but I'm just going over this. Right, so one of the things which we want to avoid is overfitting, right? And so the split essentially, avoids, overfitting. So we ensure that we randomly split the data, and 80-20 is a good, ratio of how we start. Right, and then we'll see how we can tune the model, right? Even though we do this, training and test set, it might not be the best model, right? So what do we do to get the best model? We'll see that in the later steps. Okay, so we'll run the steps one by one, right? So we are just reading the data again back from the table. Now we will split the data, right? And this is how we split. We use a random split. We do 0.8. So this is 80-20. And seed is basically, right? So when we seed, it ensures that it will randomize the data exactly in the same way the next time we rerun the code, right? So that is why we use the seed. So let me just run this. So we have 557 training examples and 155. So it split it exactly into 80% and 20%. Now we will try to come up with a baseline model, right? So before that, we will create we'll create a survival status attribute, right? So the average is 0. So we'll just create a new column, right? And we will try to, we'll call it prediction. And we are putting the value of 0 into our data frame. So that is what we are doing over here with column, and then adding that column. So all your rows have zeros in them. And we are trying to predict this value through our model. So metrics is a very important aspect, evaluation metrics in any data science pipeline, right? So a very common evaluation metric is accuracy, right? So this is the formula for accuracy: true positives plus true negatives divided by all the different outcomes, right? Gives you the accuracy. Right, so we will try to use the accuracy metric, and we will define the evaluator. So over here, we are using a multi-class classification evaluator. And this is the prediction column. This is the label column. Sorry. And this is the accuracy, right? So we are trying, we are creating the evaluator. Now we will use the evaluator method and this is how we track the experiment, right? With MLflow, So we name it as the baseline model, right? And then we are trying to evaluate now. It's running, it'll take a few seconds. Yeah. So as you can see, it's a okay model, right? 52%, 53% accuracy, not so great, right? But not too bad at the same time. It's very simplistic, right? So so decision tree is another, very popular, method used for classification, right? So kind of gives you more visibility in terms of, the features, which features are kind of influencing your model. And then based on that, it kind of provides that explainability, which is sometimes required in your models, right? So let's try to build a decision tree, right? So over here, it's using the decision tree classifier. So we will take all the features, but except the first one. So this is what it is doing. And then we will try to train that, model, right? And then we will log that experiment in MLflow, right? And by the way, this is how you see the experiment, right? So over here, as you can see, this is how the MLflow is logging each of the runs. Okay, so running this. It'll take a minute, not more than that. Yeah, so it's done. So it came up with a decision tree classification model, and we are printing that to see what was the decision tree which was created, right? So this is how it looks like. So it's taking the feature 5, and then if it's 0, then predicts 0. If not, if feature 0 is less than 2.5, right? So this is how it came up with the model, right? And we can also do a visualization of that model. Yeah. Pretty impressive, right? So now we will try to evaluate the feature importance, right? Which are the features which are important as per this model, right? Decision tree classification model, right? So we see there are two fields or two attributes which are very important, right? The sex index, right? Whether you are male or female, and then the passenger class, right? These two kind of determined who all survived in Titanic, right? And that is what we are trying to show over here. Right now we will try to evaluate the model performance. Yeah. And we will capture the accuracy for the model. So it's 0.78, 78%, not too bad. So yeah, as you can see, it captured that as well over here. Right now we will go into model selection, which is the next topic, right? So we've tried to basic models. We will now try to see how we can use MLflow to manage the model lifecycle, how we can tune the hyperparameters and capture that information, and how we can automate that whole process. And then the MLflow, how it will capture each of the parameters and then help us come up with the best model, right? With the cross validation, what we will do in the below, right? So we will use the k-fold cross validation methodology to come up to evaluate and validate the model performance. And then we will register that model into MLflow. Yeah, so in the earlier lessons, right, in the earlier notebooks, we saw that we are doing, there's a classic mistake, right? So we are trying to train and evaluate the model on the same data, right? So obviously it will lead to overfitting, right? Because the model performs well on the data. It has already seen the data. So, but if it's seeing any random data, any other data, it will not be able to predict properly, right? So to solve this, basically we should use something else, right? And that is what we are saying here, right? So we use a process called cross validation, right? A k-fold cross validation, where we break our data set into multiple subsets, right? And we train on the particular subsets, and we validate, and we don't use the test set, right? We use the test set only in the final evaluation to see if our model is working well or not, right? So this the hyperparameter tuning is the process. If you don't know what hyperparameter is, right? So it is basically all the parameters of your machine learning model, right? So it could be your iterations, it could be the complexity of the model, it could be certain other attributes, which maybe statistical attributes, which can influence how good or bad your model can be, right? And you kind of need to tune that so that you get the best model, right? And this is hyperparameter tuning, right? We can automate it, as you can see below. We'll see. So we will use the grid search methodology to try every combination of your hyperparameter, right? So let's run it again, right? So we are splitting again into 80/20, and then we will create a parameter grid, right? So param grid builder is what we typically use, right? It will allow us to string all the different possible hyperparameters, right? Or the range of hyperparameters which we want to use. In this case, we are using right, max depth and max bins, right? And we create so this is just creating this values where it will just add these into your fine. When we run our cross validation, we will just pass the param grid, right? It will just create a string which we will pass, right? So there are different ways of conducting cross validation, right? Okay, a k-fold cross validation is used when the training data set is divided into, as I said, right, into k smaller sets or folds, right? The model is trained on k minus 1 fold. So if we split it, if we create a 10, if we do a 10-fold cross validation, it will train on the 9 subsets of the training data, and then the last subset it will use for evaluating its performance, right? So again, we will run the same thing. This time we are doing a multi-class classification evaluator, but this time we are doing a cross validator, right? We are doing cross validation. So we will pass the param grid, we will pass the evaluator, the number of folds. We are using k is equal to 5 over here, and the seed, right? And then we will add a stage, right? So what we are doing over here, let's see. So it will run, it's, as you can see so many Spark jobs are getting triggered, because it's running all of those combinations in parallel, right? So number of attributes into number of folds into number of rows. Yeah, it'll take a while, maybe a couple of minutes it will take. Almost done. think last few are left. So this is how we can look at the different scores, right? Once it all comes, it will come in at the sidebar, right, with the experiments which we are. Yeah, so I think it's done. Took 2 minutes. Now we will try to access the best model, right? So this is how we do it. So it got the best model, which is using depth is equal to 5, number of nodes 31, and a number of features 7, right? So as you can see over here, all the experiments are logged, whatever it ran so far. And I'm sorry. Yeah, I can go to the other UI and you can see in details what all it ran, right? So yeah. So as you can see over here, it ran so many experiments parallelly, right? And we can see there are few which did very well, and there were few which did not do so well. So if we sort on the average accuracy, we can see, right? But we need not do that, right? So there's a way by which we can pick the best model with this option, right? And now we will try to evaluate its performance using the test set, right? So we take all the values from which we captured above, right? The best depth, the best bins, and then we pass it into the decision tree classifier, and then we train the model, and then we test it. We test it and we see how accurate it is, right? This is it's doing it with the unseen data. Yeah, so the accuracy is pretty good, 82.5, 0.825. Now, right, we can create we can register the model, right? So this is how we register the model using MLflow, right? So let's run this, right? So it created a model, Titanic model, with a name, version 1, right? Models, see over here. So the model came over here. This is what we registered. It's still registering. As you can see over here, registration is pending. It takes a minute to register the model. Right, and now so we can, as I was saying, right, the MLflow model registry, you can define your model stage. So you can have these options: none, staging, production, archived, right? So every stage has a unique meaning, right? Stage is for testing, production is for the final deployment, right? You want to deploy it into production for your end users consumption or your application consumption. So we will run this once the model is registered. Let me just check. It's still registered. Takes a minute, I have noticed. Yeah, if it doesn't register, then if I try to run this, it will give an error. I'm just waiting for this. Right, so basically over here, what we will try to do is we will say, yeah, this is ready for production. So we are just saying, okay, we will transition this model for production usage, right? yeah, I mean, this is not typical, but this is just an example trying to show over here. You would obviously train multiple models and then come up with the best. Yeah, so see, now it's registered. So now we can run this. Yeah, so go back to models. Yeah, see, the stage got updated. Previously it was blank, it became production. So that is what we did over here. Now we will get the version. So version is 1. We can have multiple versions, right? So this version is 1, right? So now come to the next topic, right? How do we serve the model, right? So we are talking about actual operationalizing of the machine learning model, right? So this for this, obviously you use your I mean, based on the organization, right? You try to use different options of doing it, right? So this is Azure architecture. So imagine your customer is on Azure, right? So you would typically use maybe a AKS, a Kubernetes service. You would create a REST API, and then you would serve the model, right? The other options are obviously you can create a API with Databricks MLflow itself, right? So we will see how we can do that as well, right? So we'll again run this, and we will just load the version of the registered model again, right? Which is 1. We just have 1 model. Okay. And then we'll see how we can, what are the different ways in which we can score. We can do scoring, and we can serve the model. It's taking a while. Yep. Then, yeah, version is 1. And then try to run this. So it's trying to upload that model, and it takes a while, maybe a few seconds, 30 seconds. Yep. So it copied the SparkML model, right, to the DBFS location, right? So under artifacts, this is where your registered model is. From here, it moved it into the temporary location, right? Now we will see how we can use it. So again, we load the data, right? So so batch scoring, very common, right? So we run every day in the morning or at the end of the day, and we see how what it predicts, right? So this is typical batch scoring. This is what we call as a batch scoring, right? So we will run our model pipeline, and we will get the prediction, right? Another option is streaming, right? So we can also stream if we have streaming data, right? And we can use Spark. We can create a stream using Spark. This is how you do it. Read stream.table. Right? And the stream is initialized. Yeah. There's another option, which is serving model as a web service, right? Yeah. So this one is done. So we can, so as we saw, right, with MLflow, right? On Azure, you have, so this is a Azure specific example. Similarly, you have AWS, options as well, right? So as we see, right? So we have MLflow on Azure, we register our model, right? We do a scoring mechanism, we create a container image, a Docker container image, and then we deploy it, right? So we deploy our experiment on Azure ML web service, right? And we deploy it as a web service, and then we ask our end users to consume from that, right? So a container service is a good choice for a quick dev test deployment, but Kubernetes is good for a scalable production deployment, right? So we'll just look at one thing over here in the models. So we can over here, if we load, see, this is how we can predict using a Spark data frame, right? So we have the model, we can load it, the model as a Spark UDF, and then predict. This is how we can do. Similarly, this is how we can do with Pandas data frame. This is another example of how you can use your model. Okay, anyways, so going to the next step. So we've come to the end. I'm just deleting all the resources, so we can take questions if there are any, and hope it kind of gave you an end-to-end picture of how we can create a data engineering and a ML pipeline on Databricks end-to-end.
Hey guys, if you have any questions, feel free to post them in the chat or put them in the Q&A.
Yeah.
And in case you need to go back and see the whole webinar again, we'll be uploading it on YouTube. Go to Top Coder channel. Tomorrow you would see and if you have any questions, then feel free to post them in the comments, and we will we'll pass on the questions to Abhishek and have them answered for you.
Yeah, in this way, I'm just cleaning up all the resources which I created. And this is the cluster. I can stop it. I'll stop it later. But yeah, hope it was a useful session, folks. And you can experiment most of the things on community edition of Databricks. There might be some hiccups with MLflow registry, but the rest works fine.
Awesome. So we get one node cluster also in the community edition, right?
That's correct. Yeah, and that is what I created as well, right? A single node cluster.
Awesome.
Yeah.
Okay. I think we don't have any questions right now for you, Abhishek. So, but thanks a lot for running the webinar. It was great learning how from end to end we start from the beginning and deploy the models, and even learning about MLflow. Thanks a lot, and we will get back to you with any questions if there are on the YouTube comments, and we look forward to more such webinars from you. And yeah,
Sure.
Yeah, thank you, Abhishek.
Thank you all.
Thanks everyone for joining.
Happy learning, and have a great year. New year. Happy holidays.
Yep.
Thanks.
Thanks everyone. See you in the forums. Bye.
Bye.